A desk holder contains 8 pens and 5 pencils. In how many ways can 4 pens or 4 pencils be selected? Well, if I draw the picture here, we have 8 pens and pencils, both P's. So I'm going to put 8, I'll just write it out, 8 pens, 5 pencils. So this is our collection. How many ways can I choose 4 pens or 4 pencils? I am absolutely not doing both of these. I'm only doing one of them. So that or is going to represent a plus. I'm either going to choose 4 pens, and how many ways can we do that? 8 choose 4. Or I need to add on the number of ways I could choose 4 pencils out of the 5. So that is the answer, but then we need to simplify that. So it'd be 8 factorial over 4 factorial plus 5. 5 choose 4. Every time you choose 4 things, you're leaving 1 behind. So remember, 5 choose 4 is the same as 5 choose 1, which is 5. All right, so let's simplify 8, 7, 6, 5, and then one of the 4 factorials cancels out. 4 times 3 times 2, and then plus 5. Okay, let's simplify this. There's an 8 upstairs, there's a 4 and a 2 downstairs, which multiply to 8, so that cancels. And then the 3 cancels with the 6, leaving a 2 upstairs. So what we have is 5 times 2 times 7. 5, 2 is 10, so that's 70 plus 5. If I did that correctly, it's 75 for the final answer. All right, number 10. 3 instructors, Busby, Butler, and Hutchinson, assign projects in their pre-calculus classes. Some students use graphing calculators and some do not. And this following table summarizes all of the information we need to be able to answer these 2 questions. Very simple, actually. So notice this is the number who used a calculator. This is the these numbers here did not use calculators. Total of 40. This is a total of 41. Busby has 28 students. Butler has 27. Hutchinson has 26. So there's a total of 81 students. So what is the probability that a student selected at random is a student of Mr. Butler? Well, we're only choosing 1 student. And how many possibilities are there? 81 students. So I know the denominator is going to be 81. So we just need to count up how many students there are of Mr. Butler. And it looks like it is 27. And you could leave your answer like this. Notice that 3 goes into both of those numbers. Actually, 9 goes into both of those numbers. Be 3 over, 27 goes into both of those numbers. So 1/3. The probability is 1/3. Basically, that's saying that 1/3 of the 81 students are students of Mr. Butler. All right, what's the probability that a student selected in Ms. Busby's, let me read that again. What is the probability that a student selected at random is Ms. Busby's student and does not use a graphing calculator? Okay, so this is getting more specific. So the denominator is 81. There are 81 students. We're selecting 1 randomly. So now we need to say how many of them are in Ms. Busby's class and do not use a graphing calculator. All right, so here's Ms. Busby's, and the number in Ms. Busby's who don't use a calculator is 15. That's the answer. And they are, and you could keep it just like that if you wanted to, just like up there. You could keep 81 as the denominator. You don't have to reduce, simplify your fractions. If you wanted to, you could divide both of these by 3 and get 5 over 27. So this would be 15 over 81. That's good enough. That's the probability. All right, number 11. An experiment consists of drawing 1 card from a well-shuffled deck of 52 cards. I already know what the denominators are. 52. 52, at least before simplifying, because we're choosing one card from a well-shuffled deck of 52, 1 out of 52. So, find the probability that an ace is drawn. So all we need to do is count up the number of aces. That's the answer. And in this one, the probability that the card is a diamond, we just have to count up the diamonds. That one was pretty trivial. So I would write 4 over 52. And on this one, I would write 13 over 52.